and through a production system of extracting information from PDFs at scale, essentially in almost infinite scale, processing that data, building data models, putting that data into a lakehouse in Delta Lake, and GCS storage, S3, et cetera, and then using DuckDB on your machine or on a serverless system to query that data to build an analytics system. If you have questions, they could be any question, like why I picked a tool, how something is working, just cut me off. But my plan is to show you that, and then as I get to each tool, essentially walk you through what that tool is, how it works, how you can work with it, like how much it costs, things like that, and kind of practical considerations for each. Sound good? Okay, sweet.
Can we dim the lights a bit so that
Yeah. Oh, this one. I think it's that second light.
yeah.
There? All right.
Sweet. Also just that. That's not doing anything. Okay. This, we're going to start with very much a demo, not in production, but we're going to start with a product called BAML. Has anybody heard of BAML, used BAML? Okay. One person. Very cool. 2 people. Very cool. Highly recommend checking it out. It's a great product. It's a great tool. We're going to start with that. What we're going to do is we're going to upload unstructured data. We're going to use BAML to generate structured data models from that data. And then we're also going to use BAML to extract the information from that model that we then built. And we'll talk about why and why that's very helpful. So you can drop anything in here. It could be a live stream, be a picture of my phone. We're going to start with just a random PDF file. I have like a bunch in here. Pretty standard. Why am I starting with PDFs? Maybe I'll even talk about that. If you're building a company and you're trying to sell it to an enterprise, 90% of the data in every single enterprise is PDF data. So being able to work with PDFs is critical. 2 YC companies this year came out that are literally just extract from PDFs. That's the entire company. They're both doing very well. Being able to extract from PDFs is a great starting point for anything that's working with LLMs that wants to sell to like big companies. So we'll take a PDF. This is like pretty standard. You'd imagine this is pretty easy, but I don't actually have a data model for this yet. Obviously, building data models is like a one-time and then continuous process, but that's not the scaling process. The scaling process is extracting data. You can break those up into 2 different systems, right? You can use a really expensive model to generate really expensive LLM to generate a really strong data model that you can validate a handful of times. Once you're happy with it, you can ship it off to a much cheaper, smaller, faster model to extract millions, billions of PDFs based on that outer data model. Take that, we drop it in here. This is the PDF. We can generate some BAML code. And what you'll see when we generate BAML code is that we generated what essentially looks like a fancy YAML schema. BAML is just a little bit of a superset of YAML. It's a very small DSL, but you can define a class, define the types, define the descriptions, checks, asserts, etc. This is very simple. This was using Gemini, which is also pretty cheap, but theoretically more expensive than a small model. And then we can execute that code. And when we execute it, we'll start to stream in as nested or complex of a data model as we want. And what's really helpful about this is that as we're getting this data back, we're actually getting back type-safe objects. We're getting back TypeScript or Pydantic-based models with type safety. So as you're integrating an LLM into your system, one of like the core pieces that people struggle with LLMs is that you're working with a lot of like arbitrary text data, right? You're like writing prompts, you're doing .strip and .replace, and you're trying to get stuff in using F strings. Very like not safe, not stable. You often will like call the LLM 6 times to hope that it gets back a JSON schema that you like. BAML kind of abstracts a lot of that. And I'll show you what this looks like in code. But the goal, or one of the goals of building LLM systems that'll make you move really quickly, is if you can get LLM-based interfaces, interactions, to essentially turn back into software. Like we know how to build software. We have incredible paradigms for building robust software. If you can get your LLMs to act like software, you get traceability because it's easy. Like there's a million tracing tools. You get retries and fallbacks and decision systems. All that stuff becomes very easy if LLMs can interface with you like regular functions. One thing we can do here is we can say, let's say, from date. So let's go, can you guys see? Yeah, I think it's pretty big. So we'll say from date, where is that? From date. Let's define a different class. call it, that's my date. And we'll say year int month int day int day int. If we just take my date, you can see that we have from and until, and we turn from date to be on my date. We execute it. I haven't actually tried this, just making this up as I go. But you can see that from date comes back with year, month, and day. What's incredibly useful about this is BAML is recompiling this schema, this essentially DSL, back into Python and into Java TypeScript in real time. Why that's amazing is that as you're building your software systems, if you were to change how you wanted an LLM to respond, you'd have to remember everywhere you call with that prompt to parse out the data in the way that you expect. Make sure that it's coming back as an int or coming back as an object. With BAML, when you change the underlying data model, propagates through your system, and hopefully you're using type checkers like TypeScript or MyPy or PyLancer, et cetera, you'll just get errors, right? You can't actually use the LLM outputs incorrectly because you can't get them if they're incorrect. So it's an incredibly useful thing for building type safety, kind of robustness around your LLMs. We'll take a look at what that looks like. So this is one that we're going to go into in a moment. You can define objects like this. You can define nested objects and everything that you'd expect. And as you change these, BAML, here I'll change something really quickly.
Sorry, can you zoom in a little?
Oh, yeah.
Probably.
Oh, too much. Okay, is that good?
You guys see back there?
Every time I make a change, you'll see, well, I saved it, or if I just make a change, BAML will regenerate this code. And it's regenerating this code into a Python file that you can then check in, and it gets versioned like all of your other code. And so you can see, like, for example, if I were to, I still have my test file. So if I were to say share.baml client, types, import NDA, and I can say NDA dot agreement type. And it knows that agreement type is a class that I defined, and it gives me back a base model. I didn't write this code, BAML generates this code. If I were to change that, for example, agreement type to just a string, I come back over here, my type checker knows and it's a string. So if I were to try to take this and pass it into some other function to do some downstream logic, it wouldn't be able to, it would fail. And that kind of like robustness around type safety is what can help you ensure that your LLMs don't just work in a demo, but they also work really well in production. Similarly, can I show this? This is like my actual code base. You can see when you write tests for, when you're using BAML and you write tests on your LLMs, they just become PyTest. Like this is just, I'm asserting outputs about JSON. I'm giving it data, it's giving me back information. I'm asserting the information is right. We're turning LLM systems kind of back into software systems, and then you get all the benefits of like traditional software systems. I know I talk very quickly. Any questions? Or does that all make sense? Yeah.
It makes sense. It all kind of seems like magic, right? Does that love a little more detail on what's happening behind the scenes over here?
For BAML specifically? Yeah, for sure. All that's happening is that a couple of really good Rust engineers built a lot of the logic that every single one of us tries to rebuild every time we build an LLM application, they package into a product. So the reason it compiles in 9 milliseconds is because there's a Rust binding under the hood. Every time you change code, they have a watcher with a webhook or with a hook in VS Code, and it's all running locally, and it just kicks off that compile process. And that compile process spits out the code like this. Like all this code was just generated by BAML, and it just spits out like this. And every time you change code, it just regenerates this. And code generation with Rust, anything with Rust, but code generation is just super fast. In terms of parsing the output of the LLM back into models, I'll show you an example of that. So we have here. They created this thing called a playground. And so you can write tests. And these are largely, I use them at least to just like test out, see what the model is seeing. And what it does is it shows you everything that the model is seeing and what's dynamic and what's not. So when you build out a prompt, maybe I'll show you that really quickly. When you build out a prompt, this is actually my prompt. There's no like arbitrary code like strings anymore. It's all typed inputs and typed outputs, which get compiled into Python functions. I see, 1 second. And so if I were to pass in something of a document and that document wasn't a string or an image or a list of images, I would just get a type error. And so then because I type this with an output, you have to in BAML, because it says NDA, when I say this, context at output format, this is pure Jinja. So like, you know, for example, I could do, if document is a list, I could say like for document documents with regular. Everyone know what Jinja is? Okay, cool. You can operate on those strings like regular Jinja. So when I say that the output type is an NDA, what BAML does is it injects into the bottom of my prompt. This is like the literal prompt going to the LLM. Says, please extract the data with the following format. BAML knows exactly what I want. It tells the LLM, no matter how complex, exactly what I want. And then they have built a bunch of essentially reflection systems that go really deep into the output from the LLM and parse them and match them to the schema that I'm expecting. And so you get like a bunch of great benefits. One of which is like, you can see the token distribution. So you can, for example, save a bunch of money by removing all the indents because the LLM doesn't have to respond with indents because BAML doesn't need the indents. You can tell the LLM not to respond with quotes over keys because BAML doesn't need the quotes over keys. They essentially handle all of that for you and allow you to really focus on software. And so, for example, I'll show you one other thing in my actual code base. If we look here, this code right here, I'm extracting like 500 different attributes in real time across, like in my product, this is extracting 500 different attributes over the customers we work with just by calling functions that are all type safe and type checked. I don't have to think about any of it.
So the BAML file sort of describes a schema
Mhm.
the LLM must follow, right?
Yeah.
What happens if there is something contradictory in part of the prompt that breaks that schema? Because all you're doing is you're just adding a prompt and giving the schema to the LLM, right?
Yeah.
So what if some user has given like a fake schema before? Would it know which one to prioritize? And
When you say the use, who's the
like,
user
for
in that case?
example, like whoever is the document, for example, that you're parsing, what if that has a fake schema in there with the same prompt? Say follow this schema instead. And then.
Oh, like some user, you're trying like prompt injection if somebody's
Yeah,
using prompt
someone
injection.
injects it saying use this schema instead, and instead of name, they've given my full name.
For sure. So it's actually a great question. One of the benefits here is that if you're going through BAML's system, if the LLM responds with a schema that doesn't match your schema, BAML will just throw a validation error. So in your code, you just catch your validation error and you kind of have a pretty good idea that somebody's doing prompt injection because it's pretty unlikely from a good model that they wouldn't just follow the schema, you know, pretty closely. And so you can handle all of those types of validation errors in the same way that if somebody were to send you a problematic JSON object to a fast API endpoint that you've type saved, you would get a good validation error knowing exactly which fields are misaligned. And so even in that, like this can handle, for example, SQL injection attacks. Because just going off that idea, if you say SQL, you can add assertions in here with like regex. The SQL must match this type of regex, otherwise BAML will just throw an error or return to you null. Does that make sense? Cool. Okay, sick. Go for it.
So, I mean, this works on the basis that the response from the LLM will come in relation to the prompt given to it. So what if we use a low-level LLM, maybe a 8 billion parameter model or maybe like Llama 3.1, and it doesn't give good enough results? Then what does BAML, how does it handle it?
If the LLM gives sufficiently bad results that BAML cannot parse it, they'll just throw a validation error and you'll just catch that validation error. The nice thing is that if you're building these types of systems and you've moved sort of things back into software, presumably you would have written the unit tests for that.
Right.
So like in my application, every PR, we actually run a few hundred of these because they're actually so cheap that it doesn't matter. And we run a few hundred on every single PR to make sure the LMs are following instructions. Well, speaking of small models, one thing I didn't, so I'll pause. Any other questions on BAML? Okay. Cool thing about this, so one of the things I didn't say a moment ago was, although we use Gemini to build this schema, because building the schema is a little bit harder, as you could imagine. It's a more complex thing. What we're using to extract the schema is actually a 4 billion parameter Gemma model. Gemma happens to be like really good. I'm very happy about it, Gemma 3. But I've tried this with a couple of others and they're fine. But this is the top part is actually a 4 billion parameter model, Gemma 3 4B, and it took the instructions of Gemini that were generated below. Why is that important? It's important because Gemini is pretty cheap, but if you have to run like billions, you want to shift from a per token usage to a per compute usage. And so like you can use Gemma hosted by Grok, for example, but you're still paying per token. Very useful at a certain point of threshold, you need to start moving to hourly based payments. And you want to just get as much as you can, scale out as fast as you can, process everything as quickly as you can. So BAML was the first tool. The second tool in the stack that I use in production is a tool called Modal. Has anybody heard of Modal? Anybody using Modal? Sick, sick. Nice, everyone's gonna start using it after this. Modal is essentially, is everyone comfortable with the term serverless? Does everyone like feel comfortable with what that means? Cool. Modal, Google Cloud Run. Modal is like serverless if it was built modern, like for today's era. What that means, what I mean by that is that you get serverless systems that you just pay by the second, by the hour, by the second, except that you don't have to write any custom code to spin up modal systems. It's just a decorator. You just add an app. I'll show you the code. And their cold start time, the time it takes to actually spin it up, whether it's on a CPU, on an A10 GPU, or on an H200 GPU, is like under 30 seconds. You can actually get a system from your local machine, a training job or an LLM job, running on Modal, processing data within 30 seconds of starting that job. Show you the apps. I have a bunch deployed. But I'll also show you what that code was to deploy. Okay. Oh, all right. I didn't save it. I'll show you the Llama one. It's the exact same code, which is great. It's the exact same code. So in Modal, they're really good engineers. They're like the original engineers at Spotify. They rebuilt the Docker build system to be significantly faster and manage caching in a much smarter way. And they rebuilt Kubernetes to handle caching in a much better way and handle orchestration of ephemeral jobs in a much better way. They use that plus pooling of nodes across like every major cloud provider to give you those unbelievably fast cold starts and unbelievably fast image builds. So when you want to define, everyone know what VLLM is? Everyone feel yeah? If you don't, it's like the easiest tool to serve models in like a production way. You want to serve an LLM on Modal in production with an API key and an endpoint. You define an image. You tell it what you want, the LLM Hugging Face to download, and then Flash infer for inference. You define the model and the SHA that you want to download. You find the volumes for caching. So the model gets downloaded to Modal's, the model gets downloaded to Modal's volumes. And then the next time the app starts up, it just loads it from the volume instead of downloading it again. And then you just literally define, a function. This is it. I'm telling Modal to use these volumes to load the data. I'm telling Modal after 15 minutes of no requests, turn it off. I don't want to pay for it, right? Keep it up for 15 minutes. Maybe I'm serving an application, or maybe I'm not, and just turn it down immediately. It's just a job. Up to 100 concurrent inputs. The GPU you want, so an A100, you can do an H100. Oops. You can do an L40S, which is my favorite, my go-to GPU because it's like pretty cheap and pretty solid. Doesn't matter. And then you literally just call the LLM serve. This is creating a web server at the port you want with the API key that you want, and it'll handle the request. So if you send it a request that isn't with an invalid key, they won't spin up the GPU. You won't waste the time. It'll only spin up the GPU once that request comes in. It'll spin up the model. It'll service the request. It'll keep all the requests in a queue, service all the requests, and it'll turn off. You'll pay like $1. because it's only actually been running for like an hour. What does that look like? We'll look at Gemma. This is the app. It's running right here on the server with an API key. And you can see all the logs. Darn, there's no logs. Apologies, there's no logs. Let's see if this one has logs. No, all right, they only retain logs for a couple days. It's okay, you see all the logs from VLM starting, and from initial request to cold start, it's like 45 seconds, and then you just have a real-time endpoint. Why is this really valuable? I'm sure like if you're on LinkedIn or on Reddit or like wherever you are reading about LLM news, people are constantly talking about like building agents and why open source models are catching up to big models. Broadly speaking, I don't like totally agree. I don't think there's any open source models that are cheap enough to serve yourself that are at the performance of the larger models on a scale adjusted basis. Like Gemini is an unbelievably powerful model, and it's like dirt cheap in most respects. But there are like two really good reasons why you need to be using open source models. One is privacy. You don't know what your customer is going to need because you don't know who your customer is yet. And there's a lot of customers who are just going to say to you, like, you can't be using the big models. They're going to save our data. We don't believe them. Or you can get like $100,000 enterprise contract with Google, which you can't afford. So you have to have your own models. You have to be able to serve your own models yourself. And the other really important reason is quota and throttling. Gemini and OpenAI and all those models are only, I mean, Claude's not cheap, but they're only cheap when you use the pay as you go. If you wanted to switch to an enterprise contract with Google and you wanted SLAs, it's like $100,000 a month, $50,000 a month. They're crazy expensive if you want to get the SLAs. And it's hard to build an enterprise product if you have no SLAs because you need to give your customers SLAs. So you have to have backups. Even if they're not quite as good as the best one, you need to have backups. You need to be able to serve models at a reasonable scale when those bigger systems go down. And so what does this look like really quickly going back to BAML? Here, it looks like this. And so this is my model that I pass into all the BAML functions that it uses by default. It starts by calling Gemini 2.0 Flash. And if Gemini 2.0 Flash fails, it moves over to Llama 3.211b or whatever model you want. I guess I didn't define Gemma in this code base, but it falls back to Llama. And then it has exponential retry. And so you can have, you can define all of these call functions yourself. It doesn't really matter. But the point is, you can assume the best, but you really have to have open source models in your stack just in case these things go down. Like OpenAI for, I don't remember which company, but they posted on LinkedIn about it a couple of months ago. OpenAI just started returning nonsense. Like they just started returning arbitrary outputs. If you were using BAML, all of the parsing would have failed and it would have fallen back to your base model, like your open source model, which you know is going to return reasonable outputs because they're just static frozen weights. It's going to return the same thing almost every single time. Your product doesn't get impacted. So it's super important if you're building LM systems that you have a way to fall back to a system that you can really trust. Any questions about modal, LLM, serving, anything like that? Yeah.
How do you compare which LLM is better for your outputs?
Yeah, great question. Evals are super stressful. Like the evals in the ecosystem are very annoying. I don't listen to a single one of them. If you're using BAML and if you're defining your input and output structures like this, it's very easy to write tests because you just write tests. And so there's a third reason to have open source models, and it's because the providers just deprecate and stop serving models. They'll give you like a 6-month window and then they'll just stop supporting them. So my product was built on Gemini 1.5 Flash. That doesn't exist anymore. So I had to move to Gemini 2.0 Flash and 2.0 Flash Lite. I wanted to stick with Lite because it's cheaper. And so I have a bunch of just PyTests that I run and I evaluated all of it. And Gemini 2.0 Flash passed every single test. Gemini 2.0 Flash Lite passed most of the tests and not all. And so my app is just running on both. For certain functions, it calls Lite, and for other functions, it calls Flash, just based on like what I needed. The reason that I say that Gemma 3 is really good for me is because it actually passed almost all of my tests without any prompt engineering. There's no other open source model that got even close. Llama, I know I'm using it here because when I wrote this lecture, a couple weeks ago, Gemma 3 didn't exist. This was the best one, but Llama 3.2 has been horrible for me. Like, I know it's a really good model. People really like it. I'm sure it's great. From my use case, it's been like not good. Any other questions?
How do we check in production if the accuracy is good? So for example, during some time when OpenAI comes up with deployment, the accuracy drops for their models or how they respond. So in the production, how do we know that the accuracy has dropped?
Yeah, great question. Back to what I was, the initial thing about BAML, which is that when you sort of coerce LLMs into acting like regular software, right? These are sort of just API specs. Now you just have API specs. So you can trace them the way that you trace every other response from every other API. You get an API, you send it to Mixpanel, you send it to like Elasticsearch or whatever your logging system is. You simply just log all the JSON inputs and outputs. BAML gives it to you. BAML does have, like, the company boundary does have their own tracing. You can like tag the functions with trace and it'll trace them. But presumably if you're not using that because they're a young company, whatever, even if you had to do it yourself, you just have a bunch of input JSON and output JSON. Just ship them to a database. Like in my startup is super young, we're moving very quickly. All I have in my application is every time I make a call, I just flush it to a queue. And then I have an asynchronous worker that's just taking those predictions and just shoving it in Postgres, and we deal with it later. That's not the most beautiful system, but it doesn't matter because like I'm just handling JSON. Does that make sense?
So, but how will we see a drop in accuracy? Are we doing it like continuously? Are we checking the accuracy of our systems?
Oh yeah, for sure, for sure. So like any monitoring or observability you want to do, it's the same monitoring or observability you would do on any product that you would build, right? Like if you're building a product and that has no LLMs in it, but you're expecting your users to work in a certain way, you still want to monitor the accuracy of that. You want to assert that they took certain paths in your code in your UI, for example. It's the same thing. You have a bunch of inputs, you have a bunch of outputs, you know what they should be. And so you just write automated tests that pull data from that system, run the checks that you expect, kind of like your PyTest. This is the input, this is what I expect the output to be. You could, for example, like trust that Claude 3.7 is really strong and like will do a good job of evaluation. And then you can run that on the back end and then you'll know if it's doing a good or bad job. Maybe one comment on that. Are people familiar with GAN networks or GANs, like that architecture? So a really useful trick that I don't see a lot of people talk about is like leveraging the concept of GANs in LLM evaluations. The whole like point of a GAN, the reason that the generator has an advantage when it's running is because it's a lot easier to discriminate than it is to generate, right? It's really easy to tell you if someone did a good backflip or not. It's super hard to do a backflip. And so same thing applies for LLMs. It might be, let's say, 6 out of 10 hard to generate the correct schema for a given input output. Much easier to say if that schema is correct or not. And so you can leverage even the same model often on a fresh call to tell you if it was right or wrong, just because of how much lower barrier it is to discriminate against something than it is to generate. At Evolution IQ, we did that. I can't say for what we did it, but we leveraged that discrimination paradigm, and we have for one component of what Evolution IQ does, we had the best performance in the industry. There was no one that matched us. We were 20% more accurate than everyone because we were leveraging that discrimination paradigm. And that was the only reason that we got there. Yeah. Any other questions?
So a comment on that.
Yeah.
One other thing that I saw on LLMs for evaluation is that if you get the result of an LLM and pass it back to the LLM again and says that it regenerated for me, and if it's able to regenerate from that result back to the data, that means that it was able actually to parse it out properly. But if it makes mistakes, and then you can basically assume that where that those mistakes coming from.
Back to the raw data?
Similar to the raw data.
Okay.
Imagine so you get the schema and you say that from this schema generate this data for me. And then you text-wise compare these two data together, see that how much similarity do you have.
Yeah, it's an interesting thing. So I'll show you like something in a similar vein, which is if we go to extract test here, like something that you'll see in some of my tests is I have functions like one of, or that's not a good one because it's just like any of, but I have one called like. Don't I have something called like? Yeah, like, okay, here. for a lot of my LLM tests, it will give me back something. They're not 100% deterministic. I always have seed set to 0 and I have temperature set to 0 to minimize like variance of the response and seed for as much determinism as possible. But they're not always perfect. And so I use a class that I just wrote called like, which is like if it's close enough to this. So like one of the things I extract is like what the profession of the person is. One of the tests is like, oh, I think it's actually like I teach computer science at Harvard or whatever. And it will sometimes say I teach computer science at Harvard, or it'll say computer science at Harvard, right? It'll say I teach at Harvard. And so like is just, so all my tests pass every single time. It's that if it's close enough to what I'm expecting, I'm comfortable with it, in the system. It's kind of like what you're talking about. If it's close enough to the data that you're expecting to see, and you can decide on that threshold of similarity, right? For whatever makes sense for your system.
So another follow-up, I think, is a similar question. What would you do when you don't know the real answer? So you're parsing these documents and you have like thousands of documents come through, so you don't actually know if the result that the fields that was extracted are correct.
Just because you're saying there's too many and you
like you cannot manually basically parse those. Also, you have a data that you parse. So I assume that what you mentioned was that as part of your testing, you have another pipeline that gets actual data and see that if the LLM was able to extract it, right? So at some point you will find errors, right?
Mhm.
Like how would you decide if that you need to update something or like what's your threshold on the monitoring?
Yeah. So that is, the answer to that question is pretty much always, or it should always be like, it depends on the product you're building. One of the useful paradigms of this type of building of LLM systems is that it forces you to answer those questions before you start building. Like by having to define BAML schemas, for example, it forces you to do product work that you otherwise would have probably skipped. And then you'd end up in a situation where you don't actually know what's correct and not correct. But if you do the upfront work to define these schemas, not necessarily, but like it's much more likely that you've talked to your customers and you've understood their needs and you've developed the schemas that align with the problem that you're solving. And so once you have that, it becomes a lot easier. That said, just broadly speaking, like the space of labeling actually there's a lot of research in the data labeling space and like how to do it efficiently and how to A/B test different labels. You can do something similar like that. So you can take all of your data, you can pass it all to Claude or whatever model you want to label, and you can take a subset of that, distribute that subset across. Let's say you hire 3 data labelers or 3 people in your team, just label all that data, and you can see cross references and you can just see the correlations, and that can tell you kind of how good or off you are.
Adding on to his question, what if we have a task, something like we take a large document and want to summarize it? How do we test that the summarization was correct if we ourselves never got to it?
Yeah, it's a great question. Summarization is a really, really interesting and difficult problem. And the way that we did it at Evolution IQ was that we started by not allowing it. We started by forcing everyone, specifically product teams, to answer the question of like, why are you summarizing this thing? Like, what are you actually trying to know about the summary? If you force them to, if you just do the summary, they'll read it and you'll end up in these situations where you spend 8 hours reading summaries and you're like, this one's good, this one's missing this. If you just start by saying, well, what would make a good summary? Almost certainly they're gonna give you 3, 4, 5, 11 different features of the input data that define a good summary. Okay, so now you have an extraction task and you can get precision and recall numbers on those extractions. Once you have all those extractions, product might still say to you, but we need to show a summary. That's very easy. Now you have a bunch of extractions. You pass an LM, all of the extractions, and you say, generate the summary based on this information. Not only that, you can take it a step further. You could say, here's all the information. When you generate the summary, cite it, right? Generate a sentence and a citation for that sentence, and a sentence and generate a citation for that sentence. Now you have a summary, the citations that in a UI you can hover and go back. Like that's what Perplexity is doing. First is always extraction, and then you can do whatever you want on top of that extraction, as long as you're measuring the extraction is good. Yeah.
How are you measuring the similarity here? Like, are you also considering semantic similarities of the sentences?
In this particular thing? No, in this particular thing, semantic isn't relevant like for what I'm doing. It's just a fuzzy match. It's just like a tool called Rapid Fuzz. It does like Levenshtein distance. super straightforward. It's just like a pairwise character similarity. But you could imagine right here, this is it. It's just the partial ratio is less than the similarity. You could just say embedding, like embed the first, embed the second, check the cosine, and fail if it's under the cosine. Cosine, like maybe I'll just throw this out if people are like new in the space, which I guess presumably you are. I've never heard of a good reason to use just saying an API for embeddings. Don't do it. Run your own embedding models. As painful as it is to migrate an LLM in an application, imagine that you have 100 million embeddings powering a vector database and that embedding model has been deprecated. The idea of transferring all the embeddings could destroy a company. It would, if you're in a big, it's a disaster. Embedding models are so fast and so good and so small today that there's never a reason to use an API for embedding models. They're free. My Mac can run like hundreds of embeddings per second with a CPU on text. Like it is never worth it. So the reason I say that is so in your tests, in literally getting baseline GitHub actions, they can power embedding models that are very, very good. We do it. I have other tests that actually do run embeddings. And so just drop the embedding model in, it'll be quick enough for tests, not gonna be a problem.
Yeah, so just.
Oh, no worries, yeah.
I think, so based on a previous statement, you mean that the main testing you do is in the retrieval, kind of like the extraction, rather than the final summary that's generated? Would that be it?
In unit testing, yeah, in unit testing or in like weights and bias level sweeps for sure, because you can just get precision recall metrics. We will do manual review and also discriminatory review, like with LLMs acting as discriminators on like summaries of things that you're citing. But those are always going to be vibe checks at some level. Like the best that you can do is what we did a little bit of evolution IQ. I haven't done it here yet. Is you can like almost sort of what you were saying. You extract, you pass the LM the extraction, and then it generates a summary. And then from the summary, you extract again, and you compare the post summary extraction to the initial extraction, make sure that they're the same. Yeah.
For summary to be accurate, it depends on the extraction accuracy, right?
Totally.
So how do you ensure that the extraction is accurate all the time? I mean, it depends on the quality of the PDF as well, right? So it's not sure that all the time your extraction will be accurate.
100%. Totally dependent on the extractions. The first way that you just build trust around that is you write the unit test. So if you think that in the industry you're working in, the PDF quality won't be very good, you got to get some bad PDFs. You got to like get thousands of bad PDFs. Make sure that you trust your system to be sufficiently robust. The second piece of it though, which is less of an LLM thing and more of like a product operational component, is if you are showing in every summary where that source of sentence came from in the original document, you won't lose as much trust with your customers, right? If you say in your summary, the total bill was $11 and the total bill was $111. But if you look at the PDF and it's clearly smudged on that other one, and every sentence you have points back to the thing on the PDF, even with like bounding boxes, for example, and your customers say, okay, like it's wrong, but I totally understand why it's wrong. Like it's clear why it made that mistake because the thing I gave it was really poor. You know what I mean? The other piece on that, if you really like are worried about that, is there are a lot of like tools, open source tools that will just tell you the quality of an image. You can just give it the quality of a PDF and it'll tell you the sharpness. So you could just reject PDFs if you cared that much that are like sufficiently low in sharpness.
In industry, you cannot reject the PDF, right? You have to still process it.
It totally depends. It depends on the contract with your customer, right? The contract with your customer could very easily be, we'll extract PDFs that are at least this good in quality. You could just give them back the ones that aren't as good. In fact, it's really like pretty critical to customer success. Like part of the role of customer success in enterprise contracts is defining the metrics that are successful and not allowing the customer to shift the goalpost when things change. So if you define that up front and then you say, look at these are the ones that were sufficiently bad. Like I have contracts with my customers where it'll say, we'll process data by this time as long as you give it to me by this other time. So if you give it to me late, I'm not responsible for giving it to you back in the given time window. Same kind of thing on data quality. That make sense? Cool. Yeah.
Let's say we have a string or a variable we are trying to extract that as a string. And how do we make sure that in some situations, maybe we need the string to be exactly the same, the word to word? Does the model actually paraphrase it even when you're trying to extract it? And if it does, how do you make sure, how do you control to?
Really, really good question. It's a common problem. LLMs, because they're like token predictors, really uncommon that it will respond with TH instead of THE if the original text had TEH. It'll often correct the spelling. One thing that you will always just add to your prompts by the nature is like do it like return it exactly, always return it exactly. That doesn't always work. It actually works like a surprisingly high percent of the time, but it does not always work. And so the backup is then you sort of have to get back to like traditional regex type systems where you're looking for the closest match of the string to the original document, finding the closest one, and then updating the text post hoc. I don't know of any tools that would one thing that we did do is we preemptively cleaned the text. And so if you have the original text and you map it to a clean text and you extract on the clean text, you can map it to the clean and then map it back to the original, right? If you go like sentence by sentence, for example.
In the prompt, your code maybe ask the model to force, make sure you're taking it, like you put in a prompt that says, of course, forcibly take the exact same string that is present.
Yeah, exactly. Like I have a bunch of, almost every one of my extractions will often come with a field that says like evidence or like quote or like proof or something. And the description, when I say description, I mean these things. I'll almost always write, this needs to be a direct quote from the original document. It, again, does not always work, but it's that's the first step. And then the second step is like if you're building it in Python, which almost certain 90% of the people probably are, you have a bunch of tools like clean text is a good open source repo and just regex in general or RE2 to try to find that closest match. And you again can reject it if it's not close enough, or you can try to find it and like coerce it. Yeah.
That would be the last question for now, but
No, it's fun. It's so much more fun.
One point you would have come across latency as an issue. How would you overcome this situation, or like what are your tips for latency problems?
For real time?
Yeah.
Yeah. It's such a product dependent question, but I'll give you like some examples from my product. The first one is obviously the UI tricks, like showing loading bars, showing like the pulsing in the UI to like make sure it seems like it's coming. Also, picking your top model, picking a model with a really low time to first token, right? So like for example, Grok GeroQ on insane time to first token. Like it's actually so fast that you often don't have to play any tricks. Like it comes in so quickly. That said, I guess I don't know the software skill set of the people in this room, but if you're working with LLMs or working with any of these systems, anything that's network bound, all of your code needs to be asynchronous, right? Like you need to be sending out only asynchronous requests. You need to be async gathering all of them, not awaiting them one at a time so that they all go out. And so like one trick that I do is one of the things we're listening to conversations of phone calls, and we're pulling out profiles of the people that are making the phone calls. So one of the things I have is like a profile, and it's a class called profile. It's 55 fields, and I'll always be reprompting the model to be continuously filling it out as it gets more information. But I also have a redundant class, which are all like one field. So it's like, what's the person's name? What's the person's address? What's the person's age? I know they're going to come quickly, and I know that the model will respond really quickly because it's 4 tokens, just like what's their name? It could be 1 or 2 tokens, and that populates in the UI immediately. So you can break down your request if you're doing everything async to grab a couple of things as quickly as possible to populate the UI while you wait for meatier pieces of information to come in. Does that make sense? Sweet. Don't listen to them. If you have questions, you can totally ask me questions.
How do you deal with scanned PDFs? Scanned PDFs with markdown PDFs. Raw PDFs.
When you say markdown PDFs, what?
Some PDFs are generated generated, but scanned videos are scanned, right?
So like.
I mean, like,
image.
it's like an image of a PDF, it's like an PDF image.
How do you?
Yeah, it's good. So that answer has changed over the last like 3 months. The original answer is like, if the PDF has OCR, like start with OCR and try to get the tables as you can out. That's like, try it out yourself, but potentially antiquated information. What I'm doing here is like in this exact one, generate BAML. This is the one that, in that little demo that we were playing with a second ago, the one that generates this BAML code. It just takes in an image or an audio or whatever. And I actually just take the PDF and I actually convert it immediately to an image. Because, and this is again new, multimodal models have gotten so unbelievably good that they can just handle images in a way that they couldn't literally 6 months, 3 months ago. So it might be worth bifurcating your pipeline, but it also might be worth just shoving everything as an image and letting the LLM take care of it. It's super dependent on the use case. For us, our PDFs, even the ones with OCR, have an enormous amount of handwriting in them, checks and like X's. OCR never does a good job with that. So we just shove it all to image processing and we handle it that way.
Sorry, this might be already covered, but I was facing a problem during one of my internships where I was making a RAG sort of model, and I used to use OCR to get the text out of these images. But my problem is that when I tried to store them inside the tables, especially, I used to always receive some sort of contextual error. So
Contextual, like semantically contextual, or
yeah, it did not capture the context of the table by when I stored them into the embedded context.
totally. Like you're saying you did you had a PDF, you used OCR to get out the text and the tables, and then you embedded that content.
Yes.
Yeah, literally this is 2 weeks old of information. This is brand new, but Nomic AI. Does anybody know who Nomic is? You should look into Nomic they're incredible. They're like the embeddings company. All they do is embeddings. They just released an open source model, which was specifically trained to create embeddings on PDFs with images.
Okay.
And so they have deep semantic understanding of images in PDFs such that you could do a RAG system where you would say something like, return to me pages in the PDF where there are line graphs going up. That's like where they built like a focus on precision. That said, if you can't do that for whatever reason, or if that didn't exist, if I gave this lecture 3 weeks ago, my answer would be to build BAML schemas on top of the images and prompt LLMs to give you descriptions that you're expecting on top of those. Oh, shoot.
You Zoom again.
No. Okay. All right, let's go to the next tool. What have we done so far? A lot of amazing questions, but we have run a bunch of things on my machine. We have the LLM on the cloud, but nothing else, right? Everything's on my machine, which is cool. But like, what's the next step? How do you actually like deal with this? There are a bunch of orchestration tools. You do not necessarily in your life need an orchestration tool. You can get away with what I'm about to show you directly in Modal. You can just set schedules and set cron jobs in Modal, just have apps that run on a schedule. You can literally use GitHub Actions, assuming you're allowed to from like a privacy and HIPAA or SOC 2 perspective. You can literally use GitHub Actions. They're amazing. You have so many minutes for free. But if you wanted to take that next step, and if you wanted to use orchestration, my tool of choice is Prefect. Where is my dashboard? My tool of choice is Prefect. Anybody familiar with Prefect? I feel like I'd expect more hands. Oh, wow, that's so crazy. Do you teach them Airflow? Is that what you're doing?
Yeah.
All right, you're gonna love Prefect if you're using Airflow. Prefect was created by one of the founding engineers at Airflow to fix all of the problems of Airflow. As an example, are you guys using like XComs to pass? Yeah. He built XComs in a weekend as a side project that was not supposed to be put into production. He has a blog post about it. It is now in production. Prefect fixes as many of the problems of Airflow as it can think. It's not a perfect tool. I've not found an orchestration tool that's perfect. Prefect is as close, I think, as you can get. It's like the best possible, I think, orchestration tool on the market. What is an orchestration tool doing for you? It should be scheduling jobs. It should be letting you trigger jobs based on events, data falling in a bucket, someone sending you a message, something failing. You should be able to configure those in code or YAML, and it should essentially get out of your way as much as possible, except when the thing fails, it should be really good at showing you where, why, when, and how it failed. That's it. That's like all an orchestration tool needs to do. And I guess, and also make it as easy as possible to get the compute to run those jobs. So why do I love Prefect? I love Prefect because in 3 lines of code, you can have all of your Prefect jobs scheduled onto your Modal account, and they can scale up infinitely. You can have Prefect schedule a job that runs 10,000 nodes instances on Modal at the same time to process all of your data in a few minutes, stream all those logs back to Prefect, get all of your failures, notify you in Slack when it fails or email or et cetera. And you barely have to think about it. Configuring Prefect to run on Modal is, I think, 3 commands in the CLI. They have this tutorial. It takes 3 minutes to walk through all of this and run the commands. It's mostly screenshots, and then you start scheduling things on Modal.
Did you write that tutorial?
I did, but I wasn't gonna say that. It's very easy, and so what happens is, it runs in Prefect. Prefect creates an arbitrary job name. That gets scheduled as a new job in Modal. Modal spins up, runs the job for you. I'll show you how all this works. It's also in the repo that we'll send out. It installs your package, sets everything up, configures within like 10 seconds, and then runs your job, logs everything, and then shuts down. And then Prefect will tell you if it failed or if it worked. Now, what does it look like to write Prefect code? Thank you for asking. I appreciate it. It looks like regular Python code. Tell me where you see Prefect. It is the tasks, and you don't have to define any of those. The only reason I do is because those happen to be the ones with the LLMs. And so I just wanted additional, I always want more and more retrying on the LLM calls, and I add a cache key. And then I create the main entry point, which is the flow. And it's just all asynchronous Python code. Like that's it. All we're doing is we're calling Python functions. We decorate it with a flow. And the only thing that's custom here is I added this function that I wrote in my code base, which again, super easy, just notifies me on Slack. And my co-founder, who gets super annoyed, I got you every time a flow fails. If you go, I'm not gonna show you our Slack channel, it's just a bunch of failures all the time. And that's it. And so you just call these functions. If you wanna test a flow, unlike an Airflow, if you wanna test it, you just say Python, this file is called process NDA, Python process NDA. It'll spin up a local work pool on your machine, stream all the logs to Prefect so you can watch them, and the whole thing will run on your machine when you want to deploy it. Prefect deploy, you define that deployment with a YAML. This is it. So how do we set it up? We clone, we pull my repo on the branch. This in production would be your release tag, right? You're using Git releases, this would be your release. Use your credentials that you store in Prefect so you can pull the GitHub repo that's private. You install UV. Everyone know what UV is? Okay, if you're writing Python systems, you should use UV instead of like poetry or pyenv or virtualenv. Switch to UV. We could talk about it for sure if there's time, but just definitely switch to UV. An install that will take like 55 seconds in pip will take like a second and a half in UV. So switch to UV. It's written in Rust. The entire Python ecosystem is essentially moving to Rust bindings with Python, Rust code with Python bindings. Polars, DocDB, UV, Modal, BAML. My entire code base is Python, but it's really just calling a bunch of Rust functions. So if you want to build tooling, you gotta learn Rust. Installs all the code, and this just defines my deployment. It defines what it is, where it is, how it gets imported, where it runs. This is my Prefect work pool, and it can connect to my Supabase environment. And like, that's it. Any questions? Somebody have a question? You had a question.
It's like the flow is a DAG, right?
The flow is a DAG.
So why do we need a cache?
Good question. You would want a cache because you could very easily get the same inputs, right? That run a second time. So like, I might have a bunch of PDFs. My customer might be really bad at naming things. and they might give me the same PDF twice, but slightly different such that, you know, a hash match doesn't actually catch it. And so if you're extracting things and you're calling an LLM based on that extraction, if it's the same input, you might as well just cache it. The other reason is, you can see here, I have flows. Oh, I actually don't have it in this code base. Retries equals 4. I'm gonna retry the whole flow 4 times from the beginning, because I said at the top. Exactly. Every task that failed will just get cached and won't have to be rerun in the flow.
And where's the cache stored?
Prefect will by default has a database where they're storing the cache. You can also then configure it to be your own system, but I don't in this code base. Any other questions?
You mentioned Superbase, so what are we using Superbase here?
Oh, in this we're not. It was just like an example YAML file, so you could see it. Superbase is just Postgres. If anybody is like playing around with it, it's great. It's super easy to start with, but it's just like.
I have a project.
Yeah. Everyone has a project on Superbase, and so it's just like the easiest one to show the version of. Someone raise their hand. Okay, cool. What are we doing in this flow? What we're doing is that we're reading from GCS, we're reading a path that's passed in or like default configured, or you like set a trigger in Prefect to run this flow every time a new file drops in GCS. That GCS bucket is right here. One moment. And this is this should be a private bucket, so you won't be able to access it. But you know, you write a block. Unprocessed. Every time a PDF gets dropped in, this code base, I maybe put too much time into it, but like this is processing NDAs. Like, you know, let's say you want to sell a product to like a law firm and process all their NDAs for them and then give them insights about those NDAs. We defined like a whole bunch of schemas. I defined every single one of these with Claude. For what it's worth, I uploaded like 6 NDAs PDFs and I had it generate all the BAML code, validated that it worked, and I moved on. Generate a whole bunch of schemas, generate the functions that I needed, the tests, we already looked through all this. This is the Jinja where we're like looping through all the obligations, etc. So we get all of those, we process the PDF. This is a coroutine. We await all the coroutines. And then inside of there, we extract everything we want to extract. There's like a whole bunch of nested fields. We flatten all those nested fields, create a bunch of polars data frames. And then we take those polar data frames and we create a delta lake. Does everyone know what delta lake house? Does everyone know what the term lake house is? Cool. Okay. All right, I'll go through it. Lake house is a pretty new paradigm in terms of people actually like using it and trusting it. Over the last, let's say 15 years, there were like 2 things. There was the database. It was Oracle, scaled up, and then we started to scale out with data warehouses. And we had a bunch of data that we didn't know what to do with, so we put them in data lakes. So we have a bunch of data warehouses with our production data. We have a bunch of data lakes that MapReduce promised to solve and then couldn't, and then Spark promised to solve and then couldn't, and then Databricks promised to solve and then couldn't, and maybe data lakes are really hard to use. And so a bunch of unbelievably brilliant people said, what if we could get the transactional consistency of a database, like schemas, schema migrations, ACID compliance, atomicity, isolation, consistency, but we could store all that data in S3. Why do I want to store the data in S3? Because all of the minutes of the day that you're not using the data, you should not be paying for all of the compute necessary to process that data. That's like why the data lake became a thing. You could separate compute from storage. But you want to separate compute from storage in a way that that data, that storage is actually processable by something like DuckDB or like polars, right? You want to be able to create data frames, do manipulations, write SQL in a way that you can trust. Delta Lake and Iceberg, I don't have any, there's a big battle and war in the ecosystem. It doesn't really matter. They're both the same. No one will know the difference. Delta Table is a little bit easier to get started with, so I picked it. It gives you schemas. You define schemas. When you make changes to those schemas, Delta Lake writes log files that can process those changes. And so when you run queries, it handles all those it reads all those log files from every insert, update, compaction, et cetera, such that you can query that data incredibly efficiently. So for example, every time you write to a lakehouse, you'll have, these are your tables. They're just folders or really just file paths. And you'll see these logs. And they're, Okay, and they're really, really easy for systems to read because they're standardized. And so what happens with that is when I say like select star from milestones where where severity between low and medium, whatever, severity and low medium, DuckDB, polars, etc. Spark will first scan all the log files and will know which parquet files have the data that maps those filters. So it doesn't have to scan all the data like we used to with lakehouse with hate all these terms with data lakes. You know where everything is, how it's been stored, all the metadata about that data, and so you can query enormous amounts of data, terabytes, petabytes of data on your local machine. And that's really useful because when you start building enterprise scale products and you build them on BigQuery, suddenly, and you have 30 customer success engineers querying your BigQuery table, you suddenly have $250,000 a month of BigQuery costs. Figuring out very, very early a cheaper free way to query all the data that you have for all of your like non-engineer technical people is incredibly important if you're doing like the new form startup that's like lean and cheap and isn't raising an enormous amount of money and like wants to be profitable and small. You gotta figure out how to get your data in a system where you can query it very cheaply. The lakehouse is the easiest way. If you have a Supabase engine, you can do an iceberg table, or you can use iceberg, and if you don't, you can literally just store it in Delta and you'll almost certainly be fine. How do you write to Delta? It's very easy. Take a polar data frame. You either write if it's a new table. If it's a table that already exists, you just do a merge. I mean, you don't have to, but that's what I always do is a merge on your primary keys. When it's matched, you update. When it's not matched, you insert. And like that's it. Takes the data, streams it, the database, lakehouse, and then you can query it. So what happens when you run this? Maybe I'll just run it. Do this really quickly. You know, least privileges. I think that's right. I think that's right. We're gonna find out. This might fail. You know what? Actually, I can even deploy it. Do I have it in my make file? No. Okay. So we'll see if this works. Demos are great. So I ran Prefect deployment run. This is the job name. So what this should do is inside of Prefect, we should see a new run that started. Right here, it's pending. And then if we go to Modal, we should see the new app was created. Here it is. So what this is gonna do is it's going to load my code base. It's going to do a clone. It's going to install the dependencies. It's gonna run the flow. Oh, it's installing. Still installing PDF something. Poplar. It's gonna run the flow, extract all the information from the NDAs, all the ones that have been that have not yet been processed inside the GCS bucket. It's gonna create the these are the logs from BAML, extracting all the information from the PDFs. And then these are also the logs from BAML, extracting from the PDFs. This is the stuff that you would log to like Elasticsearch, for example. And it's gonna take all those PDFs, it's gonna flatten them into the schemas that I want that are partially from BAML and partially from my flattening functions. And it's going to push, and it worked, it's gonna push those right into the lakehouse. So that actually just ran a processing job, could have been at any scale that you wanted, extracted the data from the PDF, shoved it into the lakehouse. Amazing. What do we do with that? The last tool that we're gonna look at is, I'm sure everyone's gonna raise their hand. Have you heard of DuckDB? Wow, okay, very cool. I'm so excited to show people new tools. DuckDB is a very cool tool. It allows you to, in process on your machine, query enormous amounts of data with spillovers to disk by just like writing SQL. They have crazy integrations. If you have a data frame, like a pandas or a polars data frame on your machine, like in a variable, you can literally query that variable inside of DuckDB. Like I'll show you really quick. So for polars, SPL, PL from dict. And I can actually just say, this is crazy, and this isn't like, there's no real reason to use this, but I can say, for example, select star from DF where A is greater than 3. It's interoperating with polars through Arrow. Does everyone know what Apache Arrow is? Sure, yeah, Apache Arrow is an underlying data protocol that allows data to be shared by different languages and different runtimes without serialization and deserialization. So polars is doing, or DuckDB in this case is doing a 0 copy read from the polars data frame. Panda, the new version of pandas uses polars, but didn't before. And every time you would like manipulate a pandas data frame, it would like create a copy. So the big kind of thing that polars introduced, you don't really need to use polars that often, but it introduced the ability to make 0 copy reads and writes. So you can query a literal data frame in memory without actually making a copy of that data frame, which allows for enormous things like streaming data in and out of sinks. Like streaming data from GCS, processing it through DuckDB, streaming it back to GCS through polars, without ever making a copy of that data and just making transformations on reads or on streams. And that's like way deeper than I was expecting to go in this conversation. I apologize, it's like not that important. Point is DuckDB like leverages these tools, makes it really, really easy to query things. What else can you do with it? Well, DuckDB has a UI. So I was saying before, to kind of close the loop, you want your customer service people, your engineers, your data engineers, data scientists, et cetera, to be able to work through and build BI dashboards on all of this data that's now in your lakehouse without having to pay for every single query, right? Like the goal is to separate compute from storage, because every one of your employees is gonna have a really nice M4 MacBook Pro, and there's like no reason to also pay for the compute on querying the data that you already have. You might as well let them query that data on their Macs. So this is DuckDB UI running on my Mac, connected to the lakehouse that I just created, and it ran right here. And so these are the results. I ran in like some pretty heavy complex queries. There's not that much data in my lakehouse, but as I scale up, DuckDB will handle that for me. Will handle the predicate pushdown, which means like filtering the data before it brings it down from the cloud. We'll do all these aggregations, and I paid just the egress cost of the data out of GCS, like just the network to send the data out of the bucket. And you can even remove that if you work with like Cloudflare's R2 buckets. It's like the same thing, but they don't charge for egress. So if your data is in S3 or in GCS, the amount you're paying for this query relative to the amount you would have paid in like a BigQuery or a Snowflake or an Oracle is pennies comparatively. You can even do, this one wasn't that big, I just wanted to like show how cool the DuckDB system is. When you start to get more data, it will handle, this data set has like 1 million records or a little bit over 300,000, 400,000 records, and you'll get like distributions of your data. Really quick ways to do data analytics. And I paid nothing for all of, I mean, you know, pennies for all of these queries. And it just looks like tables, right? Like you're just setting up tables against your lakehouse. That's sort of closing the loop on, and so maybe one more point on this is like, let's say you wanted to build a dashboard, like a Looker dashboard, et cetera. Usually they're powered by BigQuery. You don't want to do that. You don't want to pay for BigQuery, but this is on your machine that's not very useful. Maybe it's a little bit, but not enough. All you do is you just deploy a Modal app that you give it up to, let's say, 60 gigs of RAM, 200 gigs of RAM, whatever you need for your system. People just query the dashboard just queries DuckDB in Modal. Modal spins up only in the moment that you need it, runs that giant query, sends back the aggregated results to the dashboard, and now you have like an almost free Looker dashboard powered by Modal with DuckDB over your lakehouse. And DuckDB gives you 30 credits, so $30 a month for free on the free tier. So you can build a lot of stuff with $30 on Modal. Yeah, I think I'll stop there. Any questions? Yeah.
What might be some disadvantages of using DuckDB?
There are a lot of parts of DuckDB that are not sufficient for like a large scale enterprise. So like, for example, DuckDB is largely single player. That means like you can connect to DuckDB instances that are in a server, but they're read-only. I can connect to this lakehouse, but it's read-only. I'm really hopeful that they build write support, but they haven't yet. That's why in this flow right here, I'm writing to the lakehouse with polars. Because DuckDB doesn't support writing. That's a huge problem. Like that's an enormous, big issue. And so if you're not a team that feels comfortable managing your lakehouse via like polars or Spark or Trino, you're gonna have to figure out how to do that yourself. So there's a complexity overhead here, but this is like a room of engineers. And so that complexity, if you're starting your own company, is almost always, well, that complexity in this case is likely worth it. If you're joining a large company and they have a bunch of data issues, that complexity is almost certainly not worth it. Yeah.
So every time we run a query, it's just copying the data that is, that is relevant to that query on your local system, and then we're querying it to the database that is present on our local system.
It doesn't, well, so when you do the query, DuckDB will scan all the log files to figure out the least amount of data it has to pull down, and it'll run that transformation while that data is being streamed, like over Arrow. And then, yes, like that resulting data will end up on your machine.
Okay, so every time we say turn it off, does the data also go away, or is it still on our system? The reason I'm asking is like, the more we query, the data kind of builds up in your system.
Right. Yeah, great question. So DuckDB is super smart about this, and there's a lot of ways to configure it. One thing that you can do, so this one you'll see here says memory. So this is just in memory. When I shut this down, it's all gone. And as I do new queries and my memory fills up, DuckDB will flush and just like reduce stuff. You can also set it up for either a permanent or a temporary DB file. Their like data format is, their file format is called .db, like db.db. And you can have it write to that and spill over to that. And that's helpful for like caching if you're gonna run a lot of the same things over and over again. And so like an example could be, I haven't tried this, but in theory, you could spin up DuckDB in Modal with a DB in the volume. And then you do the queries and it'll push those to the database file in the volume such that the same query run over and over again will maybe be a little bit faster because that data will already be on disk.
Does it also like check if there have any changes?
I don't know how cache invalidation works. I don't have the answer to that. I'm sure they're doing something smart, but I don't know the answer to that. Any other questions? Cool. This was it. This was everything. All the tools I like.
Do you have a demo of one live document scanning?
I just did that.
Oh, you did?
That was the job where I said prefect deploy.
Oh, I see, okay.
That was this job, which then ran this modal job in the server.
And then
pulled down all the secrets from Prefect and Modal, processed that data, and then pushed it. And we can, I mean, if we go here, we'll see those results right in here. So like, come in here. These are the part files that were written to, oh, so useful thing. I had already processed this file I happen to know I've already processed. And you'll see there's two part files because the way that this is able to be like as fast as it is, it's not like a transactional engine, but the way it's able to be fast is that it's always gonna write the part files. And then the log files are going to contain the instructions on which part files are old and useless and no longer needed. And which ones to read from, so that anybody using the Lakehouse or the Delta Lake interface will know how to read these JSON files and will know what to do with them. We'll know which part files, and when I say part, I just mean like parts of Parquet files to skip, which ones to read. And then so typically what you'll do with a Lakehouse is you'll run a compaction every week, every month, doesn't matter. And all a compaction is you spin up a job on Modal or wherever, and you run the compaction command, and it will look through all the log files, it'll find all the part files that should be deleted, and it'll just delete them from your storage. Or it'll combine them into larger Parquet files because there are advantages to having fewer large Parquet files. There's a whole world of optimization. Another downside is like those optimization tricks are not handled for you.
So I think what I want to do is that most of our students, they have as you know, for the Expo, they have a product they're working on. And most of you are doing some sort of like a RAG, chatbot, and something like that, right? So I want you guys to think about what you are working on right now and the data that you are getting back if you're using LLMs especially, and how you are parsing that data in order to pass it to your dashboard, how are you basically structuring that data. And if you have any question that you think of, like how you can connect, probably right now you have already some way of structuring your data, but how you could use something like BAML to maybe improve that format instead of having like hard coding it. I think that would be a great place for you. Not necessarily you need it for your expo, but for improving what you are building. So if you have any question on that end, like you can that's like kind of like a domain specific because all of the projects are kind of like different. But I think that's a good time for you to ask a question.
Also, BAML has a super lively Discord. I'm in there a lot. People are asking an enormous number of questions. They have been holding a live stream, which has been pretty informative. They've been doing it this week around like how to extract hundreds of thousands of attributes. And today's was like how to replicate thinking, like, when they say thinking models, like how to replicate that without having to pay for thinking models, things like that. They've been pretty good talks. I think they're going all week.
Tool you can use for scraping websites instead of PDF.
For scraping websites, there's like a few. One, it depends how you're scraping. If you need like automated scraping, the fire crawl is quite good. I'm sure that people have seen that. The other thing, if you need it like beyond scraping, like scraping can only go so far, but if you need to actually like crawl a website, like browser base is quite good. I've been playing around with browser use. It's like an open source GitHub project to control your browser on your machine, but it's all written in LangChain. I really don't like it. And I've been trying to port it to BAML, but I haven't had enough time. But it works kind of if you wanted to try it locally. I've used it for medium scale things. I would not trust it in production. If you wanted to trust it in production and not have to think about it, browser base is probably the move.
Have you tried to, like, imagine you parse out some HTML and convert it to a BAML, but how does that work? It's good at.
So I've talked to Vaibhav about this,
Alright.
CEO of BAML, and I was like, you should make your parser such that I could just give you HTML and a BAML schema and you give me that back. That's super cool. He doesn't do it yet. You have to go through the LLM intermediary. You have to say like, here's the HTML, here's the schema, return it from the LLM, and the LLM will do the cleaning and then BAML will do the rest.
Okay, that's cool. Any other questions?
Yeah.
The question is about BAML. So I thought it started as a company, but the way I envisioned it. But what are the bounding boxes? I thought it was identic like schema validation thing, and then we had the snippets where it defined the logic such as number of retries for following the LLM and doing that. Where does it start and where does it end? Like that's the part.
Yeah, it's a good question. I mean, that's probably a question for Vaibhav, like how far he's trying to go. I'm sure he's trying to take over the world. But the fundamental primitive is a much better version of type safety and schema validation on LLM outputs versus something like Pydantic AI, right? Pydantic AI just uses like the tool use parameters, which really constrain model outputs and typically hurt performance. And also, they're not doing anything special. If the LLM just doesn't follow your tool, they just have it retry with a different temperature. Whereas BAML just uses raw inputs and outputs and maps them. They're adding a bunch of other stuff. They're adding like observability and they're adding like the clients and the retries and stuff like that. And it's all great, but the fundamental primitive is turning all of your LLM work into functions and type safe functions.
So there's no requirement from the LLM side to have native tool use, right?
No, that's why it's so great. There's a bunch like, I don't even know if I have not looked at tool use or function calling or even honestly MCP at all since using BAML because I just define classes and functions and they just go in and out. And like, because all these models are token predictors. They're like looking at inputs, they're looking at outputs. And so you want to be as like unconstrained as possible, let it do what it needs to do and you get the output. And that's sort of where BAML sits in that flow.
So I've been using for my model deployment Vertex AI. Instead of Vertex AI, if I use my model, the one which we were talking, how can I connect that with my, I'm running my application using GK. So is it possible to connect? Will it be sufficient or will there be any issues connecting model and GK? Because connecting from Vertex AI to GK, it's very easy because it's GCP. But using other other completely different product with GCP, is it possible and is it easy?
You're saying if you were running code not within GKE, if you were running your code itself in some other environment like Modal or like Prefect, how do you connect? Yeah, Google is like not the best with their IAM stuff. It's pretty annoying and confusing. Google has two entirely isolated, separated ecosystems that like barely talk to each other and don't know about each other. There's Vertex AI. And if you're using Vertex AI, you're typically like a company. We use Vertex AI. You get like a little bit better quotas. You get models earlier. You get better support. There are no API keys. You have to authenticate through service accounts or through federated identities. If you're using Google AI Studio, pretty similar. They finally built an SDK that works for both. And Google AI Studio uses API keys. It's a little bit less reliable, et cetera, et cetera. So if you're using Google AI Studio, you want to connect to Gemini through that, you just get an API key and you store it in a secret. If you're using Vertex, which what we do, it's very annoying. You have to create a service account. You limit its scope. I mean, you could do whatever you want, but you ideally would limit that service account scope to like just Gemini. That's what mine, that you saw the path to it on my system. That I downloaded it for this talk. You get that service account, it's a JSON object, and then you store that JSON object as just a string in whatever the block or secret is of the provider, and then you marshal that back into an object. Like, oh, it's so gross, but I'll show it to you. It's in this repo. I mean, you guys can. This repo is open. Shoot.
They do have access to this.
Yeah, this repo is open source. So everything I've done today, just like you have to set up the prefect and make the accounts and stuff, but it should work. Should. And if you see in shared, there's all this nasty stuff to work with Google. So right here, I stored the service account for that connects to Vertex in Prefect. I stored it in a Prefect block. We load that right here. This is a Prefect, they call it Prefect block, Prefect GCP. This loads a JSON object, and then we create a temporary JSON file on my system. And we open that JSON file, we dump the data into that JSON file, and then we set the path to the GCP credentials. This is horrible. I don't know why they're doing this. The only tool that makes me do this, but this is how you do it. And if you make sure that this is the first thing that runs before any of your other tools like import and integrate, that's why I put it in the init of my shared module. It's like the first thing that gets imported, happens before anything else is imported, you'll just be authenticated.
I think it's similar to on your CI/CD and GitHub action when you first authenticate that the code runs. That will be the same story.
Shoot, I forgot to show you that last piece. I mean, I'm sure you're all using GitHub and CI/CD. I just wanted to show how unbelievably easy that is. If you set your Prefect API key and URL, this is the entire CD pipeline for my Prefect code. So as you change your Prefect code or you change the prefect.yaml file, this is it. And it just deploys your Prefect jobs, your deployments, so that they can be rerun and always be using freshest data. Same thing with Modal. If I change any of my Modal applications, I just call Modal deploy, and in my make file, see Modal deploy, just is a single line code, deploys, saves the GitHub SHA, and then it's live in Modal. So like it turns CI/CD into a very, very easy system, which is important. It's like great. I don't know if everyone agree. I'm sure people will not agree with me, but like there's a lot of, when you're starting a new company, there's a lot of stuff you can over-engineer. There's a lot of like pre-abstractions you can do, and they're often very problematic. Like you'll get yourself stuck. You'll think that every customer is going to be the same. You'll build a bunch of abstractions. You just edit an environment variable, everything will propagate. It almost never happens. The one thing that I personally always do when I'm building something new every single time is I set up CI/CD. You do not want to get stuck in the case where you're deploying on your computer, because you'll hire an engineer and then they'll be screwed. And they like have no idea how to get things into production. Documentation, even though it'll go outdated, is very worthwhile from the get-go. Every repo I ever start has a folder called infra and a file called readme. And I just am jotting things down as I'm dealing with infrastructure. And I always set up CI/CD. Like I always run MyPy and Pyrite, whatever, on your code. You don't need to write tests, but you at least need to type check. And I always have CI/CD such that everything's always being deployed. New company, main is prod, like that's totally fine. Things will change. As long as you're not deploying from your computer, you'll be very, very happy in 6 months from now.
Is UV on all the packages like Pip has?
Yeah, UV is using pip under the hood. Like it's a drop-in replacement for pip. It just downloads and compiles everything through Rust instead of through Python, and so it's about 1,000 times faster. But like creating a new project, UV init creates a new project. UV add updates your Py project and creates a lock file for you. UV remove, UV run. You just replace poetry or pipex or whatever thing you were doing with UV, and it'll sort of all work. There's a bunch of cool things, but like all you really care about when you're building at least Python applications, all you care about is that you have a Py project that defines your dependencies and your rules. Everything should just like be in your Py project toml. Your lint rules, your type checking rules, everything you want, all your dependencies in your groups. And then if this is an app that's being deployed, like it's an API, it's a server, it's like a modal application, whatever that is, all that matters is you have this and you have your lock file. As long as you have those two things, you got a lot of flexibility with what you do. There's a lot of best practices, but these are the cores. You have a lock file and you have a Py project toml. You just make sure that what you're testing locally is always going to be the same as what's running in production. If you're building like tooling, like an SDK, that's not it's different, it's not this. But if you're building like an application, Docker image, a fast API app, whatever, that's being deployed, as long as you have those two things, you're in a good spot.
One of the ways like you're enforcing like structured outputs from the LLM, because I didn't know about BAML before, was using instructor and Pydantic within that. I think there was a course recently dropped by deep learning.
Yeah.
It's on the same thing. So how does that compare to BAML? And because I think in instructor it just enforces JSON from the LLM side, and then
Exactly.
if it doesn't, it just fails and then retries, and then it run like 10, 20, and then one of them works out.
That's the difference. Like you just described it, right? Like Pydantic AI is totally the right spirit and the wrong implementation, in my opinion. Because it's forcing LLMs to use JSON mode, or it's JSON mode. It's forcing LLMs to use function calling, like that construct, which means that those LLMs have to be trained on those things, which means you can't use those tools if they weren't trained on those things. And if they're not perfect, then you have like a bunch of problems like that. I'll show you, I don't have a good live example of that, but let me just show you like this, for example. I do this all the time. A lot of my prompts that are complex, I will ask the LLM to think out loud. I'll say, just write a bunch of thoughts and then return the JSON. Like this, right? Like, here's the answer. JSON, invalid JSON, nope, like, whatever. Even if the quotes weren't there, anything else you need. Pydantic AI would fail. This is not valid. Then we'll get it back for you. It'll pull that out. This is the key, is that you're just asking it to write text. And as long as it's close, it'll just work. You don't even actually